Hey class, Mr. Moydeen here with another example dealing with mathematical finance in the applied math course. Here we're comparing two different loan types and different interest rates and figuring out which one is the most optimal or the optimal choice. So let's take a look. We need a new refrigerator in this case, which means we have to borrow $900 of the $1,600 price. So we have some money, just not enough for the whole thing. Two stores are offering you credit cards, one that charges 20.2% discounted interest, and another that charges 20.6% interest compounded continuously. Which card should you take? Now, implied here is the one that the one that requires the least or the lesser amount to pay back, right? So we're looking for which one has lesser interest in terms of actual amounts. So a couple things to take away from here. Even though we were given these numbers, it's important to figure out how much are we actually borrowing. Well, it says explicitly we're borrowing $900, right? So that's going to be an important factor. We're given one credit card which has this rate in a discounted manner, and another that has this rate in a continuously compounded manner. So we got to consider both scenarios. So let's look at the discounted rate first. That's the method we learned first. So the discounted rate formula is this one right here. We just saw in the previous video, actually, where the amount that I receive is going to be $900. The amount I have to pay back is going to be L, 1 minus my rate, which is 20.2%, so 0.202, times the time in years, which I forgot to mention in this problem. How about that? My mistake. Let's say that this is going to take us 2 years to pay back. So, note to self, change this problem for next video. Anyhow, 2 years, sort of arbitrarily added there. 2 years to pay back the refrigerator loan. Sounds reasonable. Alright, let's take a look. So we have all of our data points looking for L. Once again, this part right here can be calculated in the calculator. So, 1 minus 0.202 times the 2 years I just came up with. 900 is equal to L, 0.596. So all I got to do is divide both sides by that amount, 0.596, 0.596, and that'll give me the amount I need to actually pay store when I pay off this amount, which is this amount right here, $1,510.07. Now keep in mind, that's the total amount I pay back. Subtract the $900 that I received, and the actual interest is going to be $610.07. That's for the discounted method. The alternative approach being offered here is the continuously compounded interest. So the formula for that is this one right here, where E is the mathematical constant dealing with this concept. So let's see, if I borrow $900 continuously compounded at 0.206 interest rate times time 2 years, well, there are no variables here. I can actually throw all that in the calculator in one go. So let me attempt to do that while juggling these materials. 900 e raised to the 0.206 times 2 years gives me this amount here that I need to pay back, minus the 900 I borrowed, gives me an interest on the continuous method of $458.85. So the discounted method was this amount of interest to borrow 900. The continuous method was this amount of interest. So it looks as though the continuous is the better option given these values. Alrighty, hope this helps.